Picture this. Your Django app is slammed with traffic on Black Friday. Users are signing up, uploading images, resetting passwords, and hammering your checkout. But behind the scenes, every email, every thumbnail, every webhook is running smoothly in the background without a single Celery worker in sight. That world just got a lot closer with Django 6.0 because for the first time in almost 20 years, Django finally ships its own native background tasks framework. For decades, the answer to one simple question was always the same. How do you run background work in Django? You bolt on Celery, wire up Redis or RabbitMQ, and pray your workers stay alive. But Django 6.0 changes the rules. It ships a first-class tasks module in core, and in a minute, you will see why that matters not just for your next side project, but for the entire Django ecosystem. Let us rewind. For almost 20 years, Django shipped without any official way to run background jobs. Every welcome email, every report generation, every call to a third-party AP I had to be hacked around with third-party tools. Celery became the unofficial standard as early as the late 2000s, but it came with real cost. A broker, a worker pool, a monitoring stack, all just to avoid blocking a single HTTP request. And here is the pattern break. What developers were begging for was not more features. They just wanted a simple, built-in, standardized API. Instead, the ecosystem fragmented. Some teams went all in on Celery. Others picked Huey, RQ, or rolled their own homegrown queues. Swapping one out meant invasive rewrites, because each library shipped its own decorators, result objects, and retry semantics baked directly into your business logic. This was technical debt hiding in plain sight. And here is the curiosity hook. What if Django itself defined the task interface and all those tools had to compete behind a single, stable API? That idea crystallized into a formal Django enhancement proposal from core contributor Jake Howard. His Django Tasks proposal drew a hard line. Django would own how you declare and enqueue tasks, while third-party backends would own storage, workers, and scaling. This mirrors how Django already treats databases or caches. You code against a stable interface, and Postgres or Redis does the heavy lifting behind the scenes. The stakes are big here, because once the framework owns the contract, every future tool, dashboard, and worker has to play by those rules. Django 6.0 is where that proposal lands for real. The new tasks module ships as part of core, not as an add-on. Every new project now has a first-class background job story from day one. Architecturally, this is a turning point on the scale of async views or the migrations framework. Background work is no longer some external system you glue on later. It is a core capability that third-party apps and future Django features can build on directly. And in a moment, you will see exactly how this new pluggable API layer works in code. At the heart of Django Tasks is one decorator, at task. You slap it on a plain Python function, and Django registers it as a task with metadata like queuename, priority, and whether it needs a task context. Tasks must live at module scope, and they take JSON serializable arguments and return values so any backend can safely store and move them around. If you set takes context to true, that first argument becomes a task context object, giving you the attempt count and the task result ID for observability. Here is the payoff. You keep writing normal functions, but they gain superpowers in the background. Once a function becomes a task, you hand work to the framework with enqueue. From synchronous code you call enqueue, pass the task and its arguments, and Django forwards that call to the configured backend. From async code, backends can expose a enqueue, the same AP I but awaited. Every call to enqueue returns a task result object, Django's single abstraction over what happened to my job. You can stash its ID in your database or send it back to the client, then later reload it to see status, attempts, return value, and error details. And here is the twist. You never touch backend internals directly. You talk only to task result. But Django's design is deliberately incomplete. Core ships no production worker, no retry engine, no cron style scheduler, and no task chaining API. Instead, it provides two ultra-simple backends. The immediate backend executes tasks synchronously as soon as you call enqueue, which is perfect for unit tests and local debugging. The dummy backend discards every task without running anything, ideal for staging or dry run environments where you must keep task calls in place but cannot allow execution. The curiosity here is obvious. Why would Django stop short of shipping a full worker? The answer is focus. Django wants to own the interface, not the infrastructure. By refusing to dictate how workers look or where jobs are stored, Django turns tasks into a pluggable API layer, not a monolithic background worker baked into the request stack. That leaves plenty of room for specialized backends to compete on performance, scheduling, and observability. And here is where the stakes jump. Entire new ecosystems of Redis workers, RQ bridges, and even Celery adapters can now align behind a single framework blessed contract. So what problems does Django Tasks actually solve? Think about the 80% use case. Most Django apps just need to send emails, process user uploads, and talk to external APIs without blocking the request thread. Password resets, onboarding sequences, webhook dispatch, PDF generation, cache warmers. Historically, you pulled in Celery for all of that and ended up running a full queue stack for a handful of functions. Django Tasks targets this band directly so you can decorate a function, call in queue, and be done. Here is the strategic advantage. Early stage projects can start with the immediate backend, enjoy clean, Django native APIs, and only later swap in a real queue-backed worker when traffic and latency demand it. No mass refactor. No ripping out Celery-specific decorators scattered across your codebase. It is an entry ramp, not a dead end. And in a moment, we will contrast this with Celery's full stack model because that is where the real trade-offs show up. Let us zoom in on a concrete task. You define a notify user function, decorate it with a task, give it a priority, a queue name like notifications, and set takes context to true. Inside, the task context tells you how many attempts have run and exposes the task result ID for tracking. From a view, you create an order, then call and queue notify user with the user ID and a message. The result object you get back holds the task ID you can return in JSON to the client. Later, another view can call getResult with that ID to report status, attempts, value, or error. This trio, at task, in queue, or a in queue, and getResult is the minimal surface every backend must honor. Now, here comes the uncomfortable part. Django 6.0 ships, no built-in worker. In production, you still need a long-running process to pull jobs from a backend and execute them. There is also no first-party support for automatic retries, no cron like schedules, and no native task chains or groups. If you want run this every 5 minutes, or only start task C after A and B succeed, that logic belongs entirely in the back end you choose. For teams used to Celery's batteries included approach, Django tasks can feel almost bare metal. So, is this really a Celery killer? Not quite. Celery built its kingdom on one promise: industrial-grade background jobs for Django long before Django cared. Celery ships a full stack: broker, workers, schedulers, result stores, and a decade of ecosystem tooling. It supports complex serialization, built-in retries with exponential backoff, periodic tasks via beat, and workflow primitives like chains, groups, and chords that can orchestrate thousands of jobs across distributed clusters. For high-throughput, multi-service architectures, Celery still dominates. Where Django Tasks hits hard is ergonomics. You stay inside Django, import from Django.tasks, decorate a function, and call in queue without touching a broker directly. For the 80% of apps that just need transactional emails, thumbnail generation, cache warmers, and simple webhooks, that is probably enough. You get a blessed API, minimal configuration, and JSON-only payloads that are easy to reason about. The real stakes are in hiring and architecture. Framework native tasks lower the barrier for junior developers and small teams, and they make it much easier to swap backends later without rewriting your whole code base. So when do you absolutely still need Celery or something similar? If you are coordinating many services, pushing thousands of tasks per second, or relying heavily on advanced features like chains, chords, and complex retry policies, Django Tasks is not a drop-in replacement. In those cases, you will still reach for Celery or a specialized backend that speaks the Django Tasks API but brings its own heavy machinery. Think of Django Tasks as the standard language, and Celery as one of the dialects that can implement it. In the long run, that could even make migrations between tools less painful. The ecosystem is already waking up. Early experiments are targeting Redis, RQ, and even Celery itself as backends that speak the Django Tasks Framework API. Just like Django's ORM or cache layers, tasks now define a contract that others can plug into. That means dashboards, admin tools, and observability stacks can be written once against task result instead of reinventing the wheel for every queue library. The pattern break here is subtle but huge. Background jobs are no longer an afterthought. They are part of Django's core story. So what should your next move be? If you are starting a new Django 6.0 project with simple background needs, start with Django Tasks and the immediate backend. Get your code written against it task and queue and task result from day one. When you outgrow it, swap in a production-ready backend instead of rewriting your app. If you already run Celery in production and it is working, do not panic migrate. But do start thinking about how a future Celery backend for Django tasks could give you a smoother, more standardized interface. Here is the bottom line. Django 6.0's tasks framework is not a pure Celery killer, but it is a massive shift in how Django thinks about background work. It gives you a clean, framework-native way to declare and enqueue tasks, covers the common 80% of use cases, and opens the door for a whole new generation of backends and tools. If you want a deep dive on specific backends or a step-by-step migration path from Celery to Django tasks, tell me in the comments. And make sure you subscribe because this story